There's a well-known investigation at GCSE level called frogs. Many of you might well have attempted that particular investigation. I want to start this particular section by having a look at that investigation, because it's going to show us why we might want to use brackets. Now, how does the investigation work? Well, what we have to do is try and interchange these coins at this side, the pound coins, with the 10p coins at this side. And we have to do it by using one of two kinds of move. We can either slide into an empty space, or we can hop or jump over a coin of the opposite kind. So here a pound coin jumped over the 10p coin. We can never go back, we must keep going forwards, and so these three coins have, with those rules, to interchange with these three coins over here. So let's just see what happens, and let's see if we can keep count of the number of moves. Not only keep count of the number of moves, but the number of different kinds of moves. Hops, remember, or slides. That was a slide, that's a hop. And the object is to do it in the minimum number of moves. Now, when I do it, it will be the minimum number of moves. Don't worry about that. But we need to keep count of how many hops, how many slides, and how many moves altogether. So, let's begin, and we'll just keep a tally here of hops and slides. So we begin, one slide. And over there, one hop. One slide. And now, with that, we want 1, 2 hops. There, one slide. Now, 1, 2, 3 hops. A slide gets us that one home, and then 2 hops. A slide gets us that one home, and then a hop gets that one home, and then a slide gets that one home. So, let's just tot these up. 1, 2, 3, 4, 5, 6 slides. 3, 6, 9 hops. So altogether, a grand total of 15 moves. Okay, when you were doing this investigation at school, or possibly you may not even have done it, what you would have done would to be draw up a table. So we'd want the number of coins on each side, hops, slides, moves. We've got our table there. So number of coins on each side. We could have 1, 2, 3, which is the case we did, 4 or 5. Hops. Well, let's fill in this one for this table here. We had 9 hops, 6 slides, and that gave us a total of 15 moves. Now we could do it for 1 on each side. Just do it quickly. 1 slide, 1 hop, 1 slide. So altogether 2 slides and 1 hop. And we can do it again quickly for these. A slide, a hop, a slide. So that's 2 slides altogether and 1 hop. And now we have another 2 hops, a slide, a hop, and a slide. So altogether we had there 4 hops and 4 slides. Now I'm not going to go ahead and do it for 4 coins. It's quite easy to do, and the results that we get will be 16 and 8 and 25 and 10, giving us a total number of moves of 3, 8, 24 and 35. Now, the object with most of these investigations is to try and arrive at a prediction. What would happen if we had any number of coins? Can we say what the result would be if we had 10 coins on each side, if we had 50 coins on each side? Because this is the power that maths gives us, the power to model it in symbols and be able to use those symbols to make our predictions. So that's what we're looking at. Can we make that prediction? Well, let's have a little look. I want to concentrate here on this column and here on this column. I actually need a few more columns because I want to look at this set of numbers. And I want to look at how this set of numbers is made up or created. So what I'm going to do is, now we've got the data that we need, I'm going to turn over the sheet and I'm going to rewrite this table on a separate sheet. And then we can analyse it without having all these bits and pieces around the edge. So we'll pick up the coins, put them to one side, turn over the sheet and begin again. So here we've got the coins and the number of coins on each side: 1, 2, 3, 4, 5. Then we had the number of hops. That was 1, 4, 9, 16, 25. Then we had the number of slides, and that was 2, 4, 6, 8, 10. And then the total number of moves, which we got from the total of the hops and the slides. So that's 3, 8, 15, 24, 35. Now, what we said was we wanted to be able to make a prediction. No matter how many coins we'd got on each side, we wanted to be able to say how many moves it was going to take us to interchange those two sets of coins. Let's have a look at this set of numbers. And let's try and relate it to this set of numbers. Well, if we look at 3 and 15, 15 is 3 times by 5. Just a lucky guess? Well, let's have a look at the next one. 4 and 24. Well, 24 is 4 times by 6. And again, 5 and 35, that's 5 times by 7. So 8. Is 8 the same relationship with 2? Yes, it is. That's 2 times by 4. And even for this top one, we've got 1 times by 3. So let's look at these numbers here, these two columns. Here we have this number, the number of coins, the number of coins, and here we seem to have 2 more than the number of coins. So if this was n, what we seem to be saying is that here we've got n multiplied by, I'm not going to write anything in there at the moment, n plus 2. Now, it's the whole of this that we want to multiply by n. Everything. Not just the n, not just the 2, but all of it. Because when we do 1 times by 3, we multiply all of the 3 by 1. When we do the 2 times by 4, we multiply all of the 4 by the 2, and so on. So this has to be held together in a bracket so that we can show we are multiplying everything inside the bracket by what is outside the bracket. So let's just leave that there for the moment. Let's have a look now at these sets of numbers. And what we do know is that if we add these sets of numbers together, we do get the total number of moves. Can we see any kind of relationship between these numbers, the number of coins, and these two? Well, it's a fairly obvious one. This is 1 squared. This is 2 squared, 3 squared, 4 squared, and 5 squared. In other words, it's this number multiplied by itself. So if we've n, we can see we've got n squared. If we look down here, each one of these relates in the same way. 4 is 2 times 2. 6 is 2 times by 3. 8 is 2 times by 4. 10, 2 times by 5. So again, 2 times by 1, 2 times by 2, 2 times by 3, 2 times by 4, 2 times by 5. This is our n again, so we must have 2 times by n, or 2n. Now, the number of moves can't change, simply because we've written it down differently. We know the total number of moves is the sum of these two terms. That must be the same as that. The number of moves simply can't change. Just because it's written down differently doesn't mean that the value changes. And so what we must have is that the total number of moves is equal to both of those expressions, and so they must both be equal. So that shows us two things. First of all, it shows us why we need brackets, to keep things together as entities, as a whole. It also shows us how we can remove brackets, because we multiply that with that to give us the n squared, and we can multiply that with that to give us the 2n. So bearing these things in mind, what we're going to have a look at is multiplying out brackets and removing brackets from expressions. Now we've seen why we need it, now we need to be able to work both ways across this equal sign. We need to be able to work from the brackets to the expression and from the expression to the brackets. Now, we're only going to go one way in this particular clip. That's from the brackets to the multiplied out or expanded expression. Coming back this way is factorising, and we'll look at that in another section. So, let's take some examples. 3 times by x plus 2. Everything inside has to be multiplied by what is outside. So we need 3 times by x, and we need 3 times by 2, which is 6. And the plus sign, because that's plus there. X times x minus y. Everything inside must be multiplied by what is outside. So with x times by x, x squared. X times by y is xy, but we are taking the y away. So we've got x times by minus y is going to give us minus xy. Minus 3a squared, and then in the bracket 3 minus b. Now we're multiplying everything inside by what's outside, and what's outside has got this minus sign attached to it, so we've got to take care. So we have minus 3a squared times by 3 minus 9a squared. Minus 3a squared times minus b. So the minus minus together gives us a plus, and we have 3a squared b. We can do this across a number of terms. So if we've minus 2x, let's say x minus y minus z. So we've minus 2x times by x, that's that times by that, minus 2x squared. We've minus 2x times by minus y, that gives us plus 2xy, and then minus 2x times by minus z plus 2xz. Okay, those are reasonably straightforward, and you can find plenty of those in textbooks and other sources for you to practice. Let's now have a look at what happens if we want to multiply out expressions where there are two brackets multiplying each other. So, let's take x plus 5 times by x plus 10. What now? Well, what I want just to go back to is a simple one, like let's say 3 times by x plus 10. Now if you remember what we did, we said, well, we'll take the 3 and multiply it with the x, and we'll take the 3 and we will multiply it by the 10. So that this was the entity we were multiplying by. Let's think of this x plus 5 as being the 3. So for this one, we would do 3 times by x. So for this one, we'll do x plus 5 times by x. So the x plus 5 is behaving exactly like the 3. Now, here we would do 3 times by 10. And rather than write it as 30, I will write it as 3 times by 10. So this is taking the place of the 3, so it's going to be x plus 5 times by 10. Here we would have a plus sign, so here we will have a plus sign. Now, the fact that I've got the x and the 10 at the end doesn't make any difference. I'm still multiplying them together, so the same rules apply. I still have to multiply everything inside this bracket by what is outside this bracket. So now I need that with that, which gives me an x squared, and I need that with that, which gives me 5x. I need that with that, which gives me 10x, and I need that with that, which gives me 50. And so we tidy up the middle bit. 5x plus 10x is 15x. And there we have our expression. Okay, this here is an extra step. We can manage without it, provided we keep track of what we've done. Notice I've got an arrow from here going to each of these. Alternatively, I've got an arrow going from that x to that x and an arrow going from that x to that 10. So every term has got sort of 2 links associated with it. So let's have a look at doing that without going into this step. Now we've seen how we can do it, can we shorten the process a little bit? So we've x plus 5 times by x plus 10. So we've got to multiply everything in this bracket by everything in this bracket. So remember, we had to have an x by x. So that's there, x squared. And then we had to have x times by 10. So that's there, 10x. Now we need to make the same links here. So that's x by 5, giving us 5x, and then 5 by 10, giving us 50. And so we end up with exactly the same expression as we had before. And again, we've got 2 arrows going into this bracket, 2 arrows going into this bracket, and then coming back we've got the same. From 10, there are 2 arrows linking back. We can use this process for brackets like this that lead us to quadratic expressions and for multiplying any pair of brackets together. And in fact, the arrows help us to see that we've completed the multiplication, because they help us to see that if we've got 2 terms here, then there are 2 arrows linking this first term, 1 with each term there, and so on. So let's have another look at some examples of this, working our way down some quite complicated ones, but beginning with some simple ones, very much like we've just had a look at. So first of all, we've got x take away 7 times by x take away 10, or x minus 7 times by x minus 10. And let's expand this as we've done before. So x times by x, that gives us x squared, and x times by, now this is minus 10, so it gives us minus 10x. Minus 7 times by x, minus 7x, and minus 7 times by minus 10, plus 70. And we can simplify that, x squared minus 17x plus 70. Let's take x plus 6 times by x minus 6. everything in this bracket must be multiplied by everything in this bracket. So we have x times by x, that's our x squared. X times by minus 6 gives us minus 6x. Plus 6 times by x there, plus 6x. And then 6 times by minus 6, minus 36. And now again we need to simplify this looking at these x's. So we've x squared. Now we have to take away 6x and add on 6x. The net effect is nothing. So there are no x's. Minus 36. So we don't always get this middle term. Sometimes, and this is an example, notice its structure, certain symmetry about it, a 6 and a 6, a plus and a minus. And the x's will disappear. Let's take another one. 2x minus 3, x plus 1. This time it's 2x, not just x, but again, everything in here must be multiplied by everything in there. So we have 2x times by x, that gives us 2x squared. 2x times by 1, that gives us 2x. Minus 3 times by x, that's minus 3x. And minus 3 times by 1 is minus 3. Here we've got some x's, we must simplify them, we've got to gather them together. So we have 2x squared plus 2x minus 3x. We're adding on 2x, taking away 3x, we still have therefore an x to take away. Minus 3. Now let's have a look at just 2 or 3 more of these. If we take 3x minus 2 and 3x plus 2. Have we seen something like this before? A minus sign and a plus sign, a 2 and a 2, a 3x and a 3x, not just an x, but a 3x. Are we going to get the same sorts of things? Symmetry suggests that we might. So let's have a look. 3x times by 3x, that will give us 9x squared. 3 times 3, x times by x. 3x times by plus 2 is plus 6x. Minus 2 times by 3x is minus 6x. And minus 2 times by plus 2 is minus 4. Got to tidy up these middle terms. 9x squared plus 6x minus 6x, no x's. And we're left with minus 4 on the end. So yes, it was another example of that kind of expression where the middle term is going to disappear. Let's make it a little bit harder and let's have a look at something with 3 terms in this bracket and only 2 in this. So we'll make that one x plus 2. But let's put in x squared minus 2x cubed plus 8. Got 3 terms here. We need to keep very careful track and make sure that we multiply everything in here by everything in there. So let's begin. X squared times by x, that's x cubed. X squared times by 2, that's 2x squared. Minus 2x now, minus 2x cubed now times by x is minus 2x to the 4th. And minus 2x cubed times by 2 is minus 4x cubed. And now we've got to do the 8. So we've got 8 times by x, that's plus 8x. And we've got 8 times by 2, so that's plus 16. And what we can see is that from each of these terms we've got 2 arrows coming. And that's what we must have because we've got 2 terms here. So we can be pretty happy that in fact we've done what we set out to do. And now we need to simplify it. And it's usually better to write down expressions with the highest power in x first. This here is the highest power in x. It's x to the power 4. So we'll write that one down first. Minus 2x to the power 4. What else have we got? Have we got any x cubes? Well, yes, we have. We have a plus x cubed and a minus 4x cubed. So that's going to give us minus 3x cubed. Sometimes helps just to put a little tick on top of them, just to show that, yeah, we've actually dealt with those. X squareds, only one, that's there. Plus 2x squared, so we've dealt with that one. Plus 8x, we've dealt with that one. Plus 16, we've dealt with that one. And so there, our answer. Let's see if we can just take this a little bit further by multiplying together two quadratic expressions. You wouldn't normally come up with something as difficult as this, or perhaps as tedious, but it's a good exercise to see if you've actually got the hang of what you're supposed to be doing. So we've got to multiply everything in this bracket by everything in that bracket. There are 3 terms here, so if we've done it right, we ought to have 3 arrows coming from each of these associating with each of these. If you think about it, that ought to give us 9 terms, in the same way that this one, 3 terms here, 2 terms there, gave us 6 terms altogether. 1, 2, 3, 4, 5, 6, before we simplified it. So we're going to have 9 terms here. Let's work our way through it. X squared times by x squared, x to the 4th. X squared times by x plus x cubed. X squared times by minus 6 minus 6x squared. Finished with that one, on to this one. X times by x squared plus x cubed. X times by x plus x squared. X times by minus 6 minus 6x. Now this one here, minus 2 times by x squared, getting a bit fraught with the brackets here, with the arrows linking them, but nevertheless we can still use it to help us check. So minus 2 times by x squared, minus 2x squared. Minus 2 times by x, so that gives us minus 2x. And then finally, minus 2 times by minus 6 gives us plus 12. This now needs tidying up, so we start with the highest powers first and write down the highest power, then the next, and so on down the line. We tick them off, as we did here, so we can show that we've coped with them. We've taken them into account. So our highest term is this one here, x to the power 4, and there are no others. Now we want the x cubes. Well, there's one there, and there's one there. So that's plus 2x cubed. So we can tick off those two. X squareds, minus 6x squared plus x squared minus 2x squared. So we've got minus 6x squared minus 2x squared, that's minus 8x squared, and then we're adding on 1x squared. So altogether that's minus 7x squared. And we can tick them off, we've accounted for them. Minus 6x minus 2x, the x terms next, altogether that's minus 8x. And then at the end, we've just got this number 12 that we have not accounted for, and so that's plus 12. So that's multiplying out brackets. Every pair of brackets that needs to be multiplied out, or indeed if it's 3 sets of brackets, you do 2 together, and then the third, with the resulting expression, is done with the third one. What I want to have a look at now is just simply removing brackets. Sometimes we get collections of expressions nested in various sets of brackets. So let's have a look at the sorts of horrible, awful expressions that people write down in textbooks and say, have a go at these and remove the brackets. So here we are, a whole set of letters jumbled together with brackets in. And what we're being asked to do is just remove these brackets and simplify. So the first thing is remove the brackets, get rid of them. So let's have a look. A. Now we're taking away B minus C. So we've got to take away everything that's in the bracket. So we've got to take away the B and then take away minus C, which of course is the same as adding C on. Plus A, no problem there, plus B, because we've got to add on everything that's in this bracket, so plus B plus minus C, which is just minus C, plus B, and then again we've got to take away everything that's in this bracket, so we've got to take away C and then take away minus A. And that's the same as adding A on. Now we have to simplify, so we have to look for all the A's, all the B's and all the C's. So let's take the A's first. We have an A and an A and an A, and they're all plus, so that's 3A. We can just tick them off to show that we've dealt with them. B's, minus B plus B plus B. Minus B plus B, no B's, and then another B to add on, plus B. So we've dealt with all the B's. Plus C, minus C, minus C, plus C and minus C, no C's, and the C still to take away, minus C. So that one was fairly straightforward. No nesting of brackets. So let's have a look at one where we've actually got some brackets nested. So minus 5x inside that bracket, minus 11y, minus 3x, minus 5y, minus 3x minus 6y, now, that looks pretty awful. Lots of brackets, and if we look, we've got a pair of brackets here covering everything. We've got an expression in a pair of brackets there. We've got another pair of brackets here, and inside we've got another pair of brackets. Where do we start? Looks a bit tricky, but what you do is you start right inside the brackets. So you look inside each set of brackets and you say, what do I need to do to get rid of one set of brackets? And you usually go right inside the most complex bit. And this bit here is by far the most complex bit. So let's begin by going right inside and looking at this really nested, embedded set of brackets and get rid of them to begin with. So if we're going to do that, we write the rest down just as it was. We won't touch it at all. We're just going to look at this bit. We are taking away everything there. So we're taking away 3x and we're taking away minus 6y. So altogether that's take away 3x and then the minus minus is plus 6y. And then that square bracket and that one. It's beginning to look a little bit simpler. We've now got this big set of square brackets outside, but we've got that one there and that one there. And we can deal with both of these together because they're no different from what we've got up there, really. So, equals minus 5x minus 11y, and then minus minus is a plus 3x, minus 5y, minus minus 3x is a plus 3x, minus plus 6y. So we're going to have minus 6y. And restore the big square bracket. I think we'd want to tidy this up. We've got lots of x's and y's floating about, so really we've got to tidy this up. So let's have a look. And we'll do it simply inside the bracket. So we don't need to think at the moment about the effect of this minus sign. We're just looking at that bit there that's inside the bracket. So with 5x, 3x and 3x, that's 11x. Minus 11y, minus 5y, minus 6y. Altogether, we are taking away 22y. And close the big bracket. And now we've got to remove this final bracket. So we have minus 11x plus a minus, take away a minus, 22y. So what looked quite an awful lump of algebra has now come down to be something that's really quite small and quite manageable. We'll just take one more because it's helpful to get this focus on getting right inside those brackets. And what you will notice, I think, is that we tend to use different sets of brackets, different types of brackets, to draw our attention to the different lumps of algebra that we've got to deal with. So here, in this expression, we've got three sets of brackets: the curly brackets, the square brackets, and the round brackets. And notice I've worked my way in, so I'm now right inside, right in the middle of this expression. So this is the one I'm going to go for first. Everything else, for the moment, is going to stay the same. Not going to touch anything else, just this round bracket here. So I've got to multiply by 2. So 2 times 10a is 20a, and 2 times by minus b is minus 2b. Put my square bracket in, put my curly bracket in. What now? I think it would be a good idea to try and tidy this up before we went any further. So we've got 5a minus the square bracket. I've got 6a plus 20a, that's 26a, take away 2b. Close up the brackets at the end. Equals 3b. Now, I've got to go for the square bracket now. These are inside the curly brackets, so it's the square brackets we tackle. I've made that look like a 6. Let's make it more clearly a b. Minus 5a, take away. Take away everything inside this bracket. So take away 26a, take away minus 2b. So that's the same as adding on 2b, and keep the curly brackets. Now we can simplify this. 3b minus 5a, take away 26a. So that's take away altogether, or minus 21a, plus 2b. Close the bracket. And now we come to the final step, almost the final step anyway. We can get rid of these curly brackets. 3b, take away everything in the curly brackets. Minus minus gives us plus 21a, minus plus 2b, so that's taking away 2b. And then now we just need to simplify this, and what we've got is 3b, take away 2b is b plus 21a. So we were able to reduce that huge lump of algebra with three sets of brackets to a very simple expression. And again, notice, where did we start? Right in the middle, with the most nested set of brackets that we could find, right in the middle, and we simplified that, and then we gradually worked our way outwards, dealing with each set of brackets in turn and simplifying as we went along, so as to make the job easier for ourselves and be more sure that we'd got the right answer at the end.